Let's start out with the base. We're going to start out with the bearing base. And I'm going to start out with my center protrusion. It's going to be circular, and it's going to have a diameter of what? 4. Ooh, that's a big one. Alright, and now I'm going to draw a rectangle. And notice how I didn't project my geometry first. Because when you're using a center point, you can go straight to that center point and draw that circular protrusion. But now, I need to project my geometry because now I need to make some things symmetric. So I'm going to project the first 2 datum planes. Alright. I'm going to make them symmetric. Or do I need the dimensions? I'm going to put a dimension in here because I'm going to retrieve these dimensions. So I'm going to put it in here. It's going to be 1. And so if I'm measuring from the center of this over to one side, measuring from one side to the other side, that's actually locating that. So on your drawing, this would be a 2x, wouldn't it? Right? I'm going to locate this side from the center. I've got to go over here and do this one too. They're 2 different features. So now I'm going to put the overall dimension on here. 5.5. And this be 2.75. Alright. Now I'm going to hit E for extrude. I don't know why it zoomed way in on me. That one, this one, and holding control to allow the other one too. And I'll always push my extrusions away from me. Now, is there any reason for this to be symmetrically extruded? No, that hole is not on the center or anything. So let's go the whole 3 inches down. There's my first piece. The next one. What do you guys want to do next? You're going to put that hole in there? We would need a hole for a circular pattern. So I would highly recommend a hole next. Let's make a hole. And it's right in the center of this part. So how are we going to locate it? Work with me. Concentric. We're going to drill on this plane. And it's going to be concentric with the cylindrical object. And now I'm going to make this one a counter bore. Now the difference in this one is the hole actually has a distance. So this one has the pilot hole comes first. It's 0.75 diameter with a depth of 1.63, and that is from the top of plane. And then we've got a counter bore of 1.25 with a depth of 0.25. The only reason that, in drawings you always have the pilot hole first, and the way that I like to explain that is that there are combination bits. There are actually countersink bits and counter bore bits that you can use. So if you use the countersink combination bit, it's going to have that 82-degree flange on it at some point. So when I come down, it's going to drill that first pilot hole, and that enables both holes to be centered as well. Perfectly centered. So that's the reason that I tell people that may be one way for them to understand that. Now, is this hole supposed to be flat? Does it tell us? So there are some holes that will have, it would be like an end mill. It will not have this pointed tip of 118 degrees. How does that describe it?
Well, yeah, what's the symbol for that?
There would be no symbol for that. You would actually make a cross section in this part to show that.
Okay.
Yeah. So we're going to leave that with a tip because it didn't tell us any other way. And say okay. And now I'm going to make a sketch on this one. Projecting the first 2 planes. And now I'm going to make 1 point with a bolt circle. So this one, oh, I'm sorry, this is not dimensioned that way. So I have that one, and now I've got to dimension these things out, don't I? So it's 0.125 in each direction. So if it's 0.125 in each direction, can I pattern this? Yeah, but I cannot show it as a pattern hole. Now, I did have, I had some students that were actually modeling in a higher end inventor class, and they were just patterning holes that were not equidistant to each side, so you really want to watch that. These are equidistant. Just like the round off, it was 0.875 all the way across and 0.438 to one side. So that was not equidistant. I'm going to finish that out. I'm going to make a hole, which is H, the alias H. We're going to use a tapped hole here. That is a simple hole. And when I come down here to this tap, I'm going to select on size. Anything over a 1/4 inch or up starting at a 1/4 inch gets something other than a number. So it's half, 13 UNC, and 2B. What does 2B mean, you guys? Inside a normal class of fit. Very good. B means inside. A is external thread. Very good. Alright, and we're going to make this full depth of thread. And okay. And now can I pattern this one? Sure. Should we make it a rectangular pattern? If we made it a rectangular pattern, it's going to want to go in rows and columns, and we would have to actually rotate one of those patterns in a circular pattern. You want me to show you that? So here's the difference. So I could say this feature in this direction, I'm going to come down, I'm going to flip the direction, and it's going to be 1.25 times 2, right? But where's my second direction? I cannot make this come over here and come down in my start. I could say that the second one could be over here, but I couldn't get another one over there. So I could say this, and then I could use this, and I could do this in, and this is convoluted, in a circular pattern around this axis. And I could say I want 4 in 360 degrees. So that's how you would get to that. Most of the time, I'm going to delete this pattern. Cancel. It says delete circular pattern. Delete. Sorry. For old eyes it is. Alright, circular pattern. Yes. 4 in 360 degrees. And say okay. So that makes them all 0.125 apart. Okay. Pardon me. I need to make a hole on the side of this part. How am I going to do it? I don't have a plane. Yeah. So I'm going to have a plane that's either offset, or I could use a plane that's tangent to the surface, parallel to a plane. Wow. Okay. Look at that. Alright. Now I'm going to select this, and I'm going to sketch on it. And I'm going to project the geometry of the top of this, where I'm going to dimension from, and probably that other plane that runs right through the middle, because this hole is right in the middle. It doesn't have a side-to-side dimension. So I'm going to put a point right on that one, and I'm going to put a dimension straight down. That one is 1.375. I created one. The plane that I selected was, let me finish out of this. The plane that I selected was tangent to surface and parallel to another plane. So then I selected this. Okay, I'm going to put a hole through there. This goes through all, and it's a simple hole. It's not threaded. And don't forget, this one is a clearance hole, so don't forget that this one actually adds clearance for a size of a screw. So this one is going to be 0.375, and it's going to be through all. And say okay. Okay, whenever you make a work feature, turn it off. Because when you get into an assembly, you're going to have all your work features and all your shared sketches are going to be everywhere. The next thing we're going to do is we're going to make that What kind of cut is that? Dovetail. It's a dovetail cut. Alright. Have you guys ever seen a dove? Project geometry. And I'm going to make it right in the center. Dove's tail goes kind of like that. They use this for joining furniture a lot. Now, anytime that you draw down to something that's projected, it's going to think that you're finished. So I had to start the drawing again. So I'm going to make this 1 inch here. And my angles are 2 times 60 degrees. And it's not telling me this. Oh, it is. It's telling me how far it is. 0.5 offset. So from the bottom or from the top? It's from this top piece, isn't it? 0.5. There we go. And now I'm going to extrude that. Select just that piece. It's going to be a cut. And I'm going to make it through all. Okay. It did? 0.5 high. Oh, man. Well, I should have known that because it didn't turn purple. Thank you. 0.5 high. Nice. Okay. The last thing that we have are some fillets. It doesn't say how many. But I'm going to tell you that they're all on all interior and exterior corners. 125 or 0.13. It's just rounding. This one, this one, this one. You can reach through the part. Okay. So we should have 8 of them. Usually you're not going to round the edges of the faces of 2 parts that are going to fit together. Most of the time when you make a seal, you're going to try and leave that as flat as you can. And I'm going to go to Tools and Materials. Did you guys see that there's an Inventor material library? Did you see the Autodesk material library? It's huge. Let's go look at it. Look. Look at all the different grades of cast iron. Different plastics. There's a plywood in there. It's because I put it in there. For my last part, it tries to keep it in my style manager. Look at all the different aluminums. This is much more in depth than what we have in just the Inventor one. And this is aluminum 6061. Okay. Gave me a little shine. So I'm going to save that part as bearing base. Ah. Okay. Do you notice anything about the bearing base and the bearing top? The center lines, I got the same center line. Notice anything about the shapes? Let me go over here and show you something. If I go here to open something, and you may not notice this because you're not looking at the assembly. Bearing. I guess that assembly isn't in here. What do you think about the shapes of them? They look kind of the same. Flat pattern, yeah, the whole pattern's definitely the same, right? Okay. Let me show you a trick. File, save as. Bearing top. Now I'm in bearing top. Alright. I'm going to delete this cut. Don't have that on there. And the sketch. Don't need that. Don't have this hole on the side, right? And I don't need that work plane. My job just got real easy. You think? My circular hole pattern's the same, but it's a different kind of hole. I got all those fillets on there too. But I'm gonna show you guys something a little bit different now. I'm gonna grab the end apart, and I'm gonna pull the end apart up right after the first feature, which is the extrusion. If I go to edit this feature, I see that the shape is exactly the same, but the depth is not. So all I'm going to do is change the depth from 3 to 2, and then I'm going to resume the center hole. Center hole is not the same. So I'm going to right click and I'm going to edit that feature. I'm going to make this a simple hole that's 3/4 inch, and it goes all the way through the part. Getting faster? Let's resume the next hole. That one is also not the same. So I can edit this feature. Oh, I don't want to move feature. Edit feature. And I'm going to change this to a counterbore. And I'm going to follow the directions there. And it's not going to be threaded. So I'm going to start out with my pilot hole. My pilot hole is the smallest, it's 0.56. It has a depth 2. Very good. Isn't that all the way through the part though? Well, what the heck? Why don't we just say through all? Right? Okay. I'm going to do that, and then I'm going to go to, it has no counterbore symbol, but I guess it is one, 1.13. And it has a depth of 0.1. And say OK. And now I'm just going to drag the end of the part down to the next one. And there's my circular pattern. Now there's something else that I'm going to do. I got to put that chamfer in there. That chamfer is a little bit different than just a regular 45-degree chamfer, right? It's 1.1 from the bottom and it's 30 degrees. So this is a little bit different. I'm going to use the chamfer command. And I'm going to come over here and I'm going to look and see what I've got. I've got distance and an angle. I've got distance and distance. I need distance and an angle. So what it wants to know is, what face are you going to be taking away? So I'm going to select from this one because I'm actually going to be measuring on that face. The edges. It wants to know what edge you're going to be measuring from. Or is that, look, what it's showing me here is select the face, and it wants to know what edge. Am I making this a chamfer or this a chamfer? That one. So what is the distance from here down is what it's asking me. It's not 1.1. 2 minus 1.1. I'll put that in there, right? And it kind of previews me. It kind of shows me this is what you're doing. This is kind of what it's looking like. Is that looking right? No. So let's go back. And we go back to my face. I want to select off this face. And my edge to be this one. Now in this distance, it's doing another distance. Is that weird? Huh? That's right. So let's go back to what we had before. We selected this face, taking this edge away, and we said that that was 2 minus 1.1, but we need to change this to 30 degrees. Does that look better? We should have put everything in before we went back and changed our face. Does that make sense? So you're going to have to, in software, you're going to have to find out what does it want from me, what is it doing, and this is kind of what Mike was saying. You kind of want to play with it and see what the software is doing to you to figure out which face that you want to select, what edge you want to select, what is it trying to dimension from, because sometimes it's not intuitive. So let's cancel this. Let's start this again. We're going to have a chamfer. It's going to remove area from this face, and it's going to be measured from this face. The edge that's going to be taken away is this one. The distance here from this edge down is 2 minus 1.1, and the angle is 30 degrees. Okay. Now, can I have 2 of these? Can't. I have to apply it, and I have to do it again. But the thing is that it saves all my settings. So I'm going to select this face and this edge. It gave me 1.1 and 30 degrees again. Is that the wrong face? I did select the wrong face. So let's select this one and this edge, 30 degrees. Looks right again. We'll say OK. Alright. Now I'm going to resume my fillets. My fillets are everywhere that I needed except for a couple places. So we're knocking all the corners down. So all I have to do is edit this feature and add this one and this one. On the side too, that's right. This one and this one. Now, something that happens, I want to show you guys. I'm going to do this in one feature like this. Because something that happens whenever you have a fillet runs like a train on a track. If it hits a corner, it's going to stop. So in a lot of softwares, you're going to run everything in one direction. I'm going to put all my rounds in one direction. Watch this. I'm going to go back to this one, and I'm going to edit that feature. I'm going to take this one out. I'm going to take these vertical ones out. I've got almost all horizontal ones here right now. And watch how it smooths everything out when I do this. If I put I've got them in 2 directions, but they're not intersecting. See how these are running vertically, these are horizontally, but they're not intersecting. I'm going to say OK. Now if I make another fillet, it goes all the way around the part. Because in those horizontal edges, I've created tangent edges, and these have created tangent edges all the way around the part. So now all I have to do is select those 2 edges, and it made a much, much cleaner fillet surface for me. You see what I mean? It doesn't want to be a fillet? Dang. It sure doesn't. Alright. It could be, but there are two faces that are being sealed together, and usually you don't put a fillet on that. So I'm going to edit this feature, and I'm going to put it on only these surfaces. Just let it be ugly.
You also have to take it off the one that's touching the front surface also. Yeah. The one on top.
This one?
No, the one on the corner facing the...
This one. Yeah.
And the other one on the other side.
Alright. There we have it. So I want to show you guys this. Okay, let's say OK on that. I want you to look at this. Now this may not be a big deal to you guys, but when you get into industrial design, you don't want little snippets like that. Do you see? I can actually see that surface, how it's different. You see it? I would have put these in and then wrapped that. But there's a if you had this rounded, yeah, it would have kept on running, but it would just wrap those 2 edges. Okay, so I've got this part made. Is it made out of 6061 aluminum too? Yep. Sweet. Save.